Good morning and welcome to the NROL-69 launch webcast. The Falcon 9 rocket carrying today's payload is currently awaiting liftoff from Space Launch Complex 40, or SLC-40, at Cape Canaveral Space Force Station in Florida in just about 8 minutes from now. Hey everyone, my name is Soumya Srivastava and I am a structures engineer here at SpaceX. Today's mission carries a national security payload designed, built, and operated by the National Reconnaissance Office, or the NRO. This mission continues the NRO's cutting-edge capability of building and developing the U.S. government's largest satellite constellation in history to deliver critical information that can only be obtained from the vantage point of space. Both the range and vehicle are currently green at the moment, and we are on track for an on-time liftoff at 1:48 p.m. Eastern Time. As a note, we will not be showing any Stage 2 or payload deployment views at the request of our customer. But there's still a lot to cover, so for now, let's meet our Falcon 9 rocket.
Hello everyone, my name is Tyler Lionquist and I'm an analyst for Starlink. Today is the anniversary of SpaceX's first launch ever, Falcon 1 Flight 1, which lifted off from Amalek Island on March 24th, 2006. Though it didn't complete its mission, SpaceX has come a long way since then.
Engine chill has started.
Falcon 1 made its final flight in 2009 before it was retired. But it paved the way for our trusty Falcon 9 rocket, which has supported 448 launches to date. Falcon 9 is a two-stage rocket developed and manufactured by SpaceX, known for its safe, reliable, and cost-effective access to space. It is also the first, and currently the only, orbital-class rocket capable of reflight. In fact, this will be the second flight of the first-stage booster supporting today's mission. Together, Falcon 9 and Falcon Heavy have completed more than 450 launches and over 380 reflights. And today, the booster will be attempting to land back on land at Landing Zone 1 at Cape Canaveral Space Force Station.
Stage 1 RP1 load is complete.
Rapid reusability drastically reduces launch costs, helps increase launch frequency, and enables a wide array of new government, commercial, and scientific opportunities in space. Lowering the cost of access to space is helping take humanity's next steps into the solar system, whether in LEO, GEO, interplanetary, or even deep space. When costs are lower, government and commercial customers can launch more missions, which helps accelerate development. This also helps commercial satellite and private research customers afford to launch more projects to space, which helps stimulate innovation here on Earth. And missions like SpaceX's transporter and bandwagon rideshare programs help make access to space even more affordable by sharing the cost of a single launch across many customers. All of this is to say, reusability is the key innovation that is making space more accessible for the industry as a whole. Back to today's mission, weather is still a watch item, but we'll let you know if there's any updates.
Coming up shortly, the transporter erector, or TE, will retract away from the Falcon rocket.
Falcon 9 tanks are pressing for strongback retract.
The TE is the large truss structure you see there next to the vehicle. So first, the clamps will open up, which should be in about 25 seconds from now. And then after that, that will make way for the retraction of the strongback. You may hear the TE referred to as a strongback from the launch team, and it does a lot of heavy lifting in the lead up to launch. It's designed to transport, raise,
Strongback retract has started,
and support Falcon 9 at the launch pad. The TE is also equipped with umbilicals or flexible lines that are used to route the vehicle's fluids, power, and telemetry from the ground systems to the rocket and payload until Falcon 9 switches to internal power and clears the pad. So we have a great view there of the clamp arms opened up. And the strongback will slowly begin to recline away from the vehicle. Now, at this point in the countdown...
On countdown 1, this is LD, pulling MD for a status check.
Now, at this
MD
point in the
go for
countdown...
launch?
Both the
Copy.
first and second stages are nearly fully loaded with 1 million pounds of rocket-grade kerosene fuel and liquid oxygen. Both the first and second stages should finish propellant loading about a minute apart from each other, with the first stage finishing up at the T-minus 3-minute mark and the second stage finishing at around the T-minus 2-minute mark. With the first, as you may have noticed, there are white clouds forming around the vehicle, and those clouds are comprised of the chilled gas above the LOX tank that is vented overboard to maintain pressure in the tank as needed. And when that vented oxygen mixes with the warmer outside air, it condenses into clouds. At T-minus 60 seconds, Falcon 9 will be in startup, and this means that the rocket's autonomous internal flight computers will have taken over the launch countdown. After that, just inside of T-minus 2 seconds, we will light the 9 M1D engines for liftoff. Just heard confirmation of LOX load completion on the first stage. The payload continues to be healthy, and the Falcon 9 team is tracking no issues on the rocket. Weather is still looking green, and the range is ready to support our T0 of 1:48 p.m. Eastern Time. And with that, we are proceeding into the last few minutes of terminal count.
So for our next major milestone, we are waiting for the call-out of second stage LOX loading completion.
Stage 2 LOX load is complete.
Great call-out, there it is. So the first and second stages are now fully loaded with over 1 million pounds of rocket-grade kerosene, fuel, and liquid oxygen. We're standing by now for confirmation that Falcon 9 is in startup at the T-minus 1 minute mark.
Ground gas closeouts.
Here's the confirmation of the gas closeouts beginning. You might notice an increase in white cloud formation near the vehicle. This is the result of a nominal groundside process where the TE liquid oxygen feed line is vented down ahead of liftoff.
Falcon 9 is in startup.
At this point, the autonomous flight computers have taken over the launch countdown, and stages 1 and 2 are pressurizing for launch. Finally, we're waiting for the final go directive from the Launch Director.
MD is go for launch.
At T-minus 32 seconds, all systems are go.
30 seconds. Fifteen seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Missions, engine full power. Go NROL-69, go Falcon, go SpaceX. Vehicle is pitching downrange.
Stage 1 propulsion is nominal.
At T plus 30 seconds and counting, Falcon 9 has successfully lifted off from SLC-40 at Cape Canaveral Space Force Station. Coming up next, the vehicle will be passing through max Q, which is the point in the mission profile where the vehicle experiences the
Falcon 9 power and telemetry are nominal.
The greatest amount of aerodynamic pressure.
Falcon 9 is supersonic. Max Q.
Great call out there for max Q, which is again when the vehicle experiences the greatest amount of aerodynamic stress. Coming up next, we'll have several events happening in quick succession, starting with MECO, followed by stage set,
Impact shell has started.
SES-1, and then the boost back burn. Main engine cutoff, or MECO, is where all 9 M1D engines shut down to slow the vehicle down in preparation for stage separation, which is where the first and second stages separate from one another. Followed by this, the MVAC engine on the second stage will light, which is called out as Second Engine Start 1, or SES1. This engine burn, lasting several minutes, will propel the second stage and the payload to orbit. The boost back burn will assist the first stage in returning to its recovery location at landing zone 1. In addition to these major events, the fairing halves will separate about 30 seconds after SES1, so keep an eye out for all of those events that are coming up in just a few seconds. And as a reminder, we will not have any views of the Falcon 9 second stage or the payload at the request of our customer.
Main engine cutoff.
Stage separation confirmed.
MVAC ignition.
Stage 1 boost back startup.
And a good series of back-to-back callouts there and views, which again were MECO, stage separation, SES1, and the boost back burn. Coming up shortly, we should hear a callout for fairing separation, but again, as a reminder, we will not be showing it on screen.
Fairing separation confirmed.
Good call out there, confirming fairing separation. We will be attempting to retrieve these fairing halves once they fall back to Earth with our recovery vessel, Doug.
Stage 1 boost back shutdown.
And a good call out there, confirming boost back shutdown.
We are currently 3 minutes and 36 seconds into today's mission. Now, the next major milestone coming up in about 3 minutes from now will be the entry burn of the Falcon 9 booster as it continues on its journey towards landing zone 1. To start the entry burn, we'll relight 3 M1D engines, which is similar to pumping the brakes to slow down the vehicle as it passes back into the Earth's atmosphere. We need to slow down the vehicle to reduce re-entry forces, which then helps us recover and reuse the first stage. During the entry burn, Falcon 9 is decelerating by firing its Merlin engines, but it's still moving really fast. This causes the vehicle to fly through Merlin's exhaust gases, also known as the rocket's plume, which deposits a layer of soot on the vehicle surface. That soot comes from the carbon-based fuel that Falcon 9 uses, and with each flight, the soot builds up a little more on the outside of the vehicle.
Both vehicles are on nominal trajectories.
Good call out there. Reusability is the key to lowering the cost of spaceflight, which enables more investments in critical space infrastructure. The Falcon 9 first stage that is supporting today's mission is performing this entry burn for the second time today, and the payload fairing supporting today's mission will be recovered for future reuse. So we should be hearing the call out for that entry burn in about a minute and a half from now.
Stage 1 entry burn startup.
Good call out there for the entry burn startup. This burn is set to last about 20 seconds, and again is slowing down the vehicle in preparation for its final burn and landing.
Stage 1 entry burn shutdown.
And there you heard the call out.
Stage 2 FTS is saved.
There was a call out for the completion of the Falcon 9's first stage entry burn. Coming up next will be the first stage landing burn, which will start in about a minute from now. The Merlin engines on the Falcon 9 first stage are optimized for sea level, and these achieve 190,000 pounds of thrust each during ascent and descent. At liftoff, Falcon 9's first stage has thrust greater than 5 747 airplanes at full power. Should be expecting the final burn in about 10 seconds from now.
Stage 1 transonic.
Stage 1 FTS is saved.
Stage 2 is in terminal guidance.
Stage 1 landing burn.
We are now waiting for Falcon 9 to land at landing zone 1.
Landing was deployed.
Impact shutdown.
Stage 1 landing confirmed.
And there you heard the call out for a successful landing of our Falcon 9 rocket. This was the second launch and landing for this first stage.
Nominal orbit insertion.
As a reminder, we will not be showing any Stage 2 or deployment views at the request of our customer. So with that landing of the Falcon 9 booster, we will be bringing today's webcast to a close. We'd like to thank the NRO for entrusting us with today's mission, and we'd also like to thank the range and the FAA for their support.
If you're interested in more launch coverage, be sure to check spacex.com/launches and follow @SpaceX on X for the most up-to-date information. Thanks for tuning in, and we'll see you again soon.
Falcon.